Hello everyone, welcome to EC Core. In today's session, we are gonna learn about another important universal gate, that is NOR gate. So by the end of this video, what we are gonna discuss is we will discuss NOR gate, what is NOR gate, its truth table, and some important laws, commutative and associative law, and then we will understand the enable and disable input of NOR gate. So let us jump into the topic. So what actually is this NOR gate? So NOR is nothing but, if you check this symbol, this is OR and this is NOT. Simply NOR is nothing but OR plus NOT. So this is NOR gate. So here we are having two input variables A and B, and my output variable is Y. So the output equation will be A plus B whole bar. That will be, we can also write as A bar into B bar. So this is the NOR gate. Since we are having two input variables, therefore the possible combinations are 4, that are 0 to 3. We will write all the possible combinations here: 0 0, 0 1, 1 0, and 1 1. So here what is the output for 0 and 0? 0 plus 0 whole bar, that will be 1. If you are writing 0 plus 1 and 1, and that will be 0, and 1 plus 0, that will be 1 bar 0, and 1 plus 1, that will be 1, and bar will be 0. So what we can observe from this NOR gate is my output will be high only if all the inputs are 0. If any one of the input is 1, then my output will always be logic 0. So this is the specialty of NOR gate. So let us understand NOR gate with an example here. So let us take a real life example, that is a street light controlled by two switches. So what we are having, I am having two switches. If the light will be on only if my both the switches are in off position. If either one of the switch goes into on position, then my street light will be off. So this is the real life example of NOR gate. So let us understand the commutative law and associative law of NOR gate. So here we are having what is commutative law? A plus B is equal to B plus A. So here written wrong. So here we will have B A. We can write as A plus B bar, and here we can write as Y is equal to B plus A bar. So A plus B bar and B plus A bar are both are same. So let us understand the associative property. So what is associative property? If I am grouping with A plus B plus C, then that must also be equal to A plus B plus C. So let us understand if the NOR gate follows this property also. So here I am having A plus A, B, C and C. Then my output will be A plus B plus C whole bar, or you can also write A bar into B bar into C bar. So let us understand if this will be equal to this one. If I am having AB, then my output will be A plus B bar. And if I am giving C, then I am NORing this with C. Then my output will be A plus B bar plus C whole bar. So this one and this one are not equal. So in previous video we have learned that NAND gate also does not follow associative law, and NOR gate also does not follow associative law. So what we can conclude from this is universal gates follow commutative law but doesn't follow associative law. We have discussed the possible question that will be asked from this property in the previous video as well. If you want to check that one, I will keep in iCard. You can check that one as well. So let us understand the enable and disable properties of NAND gate. So here I am having control signal C with the two input variables. Let us check if see what will happen if C is equal to 0 and for C is equal to 1. So if I am having C is equal to 0, then it will be A plus B plus C 0 whole bar. Then it will be A plus B plus 0 will be A plus B, and that will be whole bar. And if I am taking C is equal to 1, then that will be A plus B plus 1 whole bar. If I am having if I'm doing 1 plus anything, my answer will always be 1 and complement of 1 will always be 0. So what we can draw from this is c is equal to 0 will be enable and c is equal to 1 will be disable. So if I'm changing the input a and b, my output doesn't change, it will always remain 0. So that is the enable and disable target. So hope you like this video. If you want, the notes will be provided in the description from this video onwards. You can check if you want to go thoroughly uh, while preparing for exam. You can go through the notes. No need to go through the video. So the link of the notes will be in description. So please subscribe if you like the content, and if you want more content, you can subscribe this channel. Thank you.